So as we bring our season to a close, our last session in our last module to acquire, analyze, and report on some forensic evidence. Basically, you'll notice that the study guide explains that you are to recovering material from chapters 3 to 5 and chapters 9 to 11 in the textbook. And you also have the slides provided by the author of the textbook in the references folder. And I wanted to tell you that you did not have to scour those chapters or these slides to learn everything that's listed there. What I would recommend you do is that you start first with the study guide and the study guide addendum. So start with the study guide and the study guide addendum. And then anything that's listed in here in terms of key concepts, especially where the student learning outcomes are concerned, anything in yellow, anything that's highlighted, right? You would basically reference some things in the slides and in your textbook. When we talk about RAID, we're talking about, is anyone familiar with the term RAID?
No.
What does RAID mean? What is RAID about? Does anyone know how or what the interest is with RAID acquisition methods?
Does it have to do something with data storage?
Yes, it does. Good answer. So RAID stands for Redundant Array of Inexpensive Disks or independent disks, depending on where you look up the acronym. But essentially, on servers, they often have disk sets. And when you're acquiring an entire disk set, that can be quite a challenge, especially if you're dealing with a large organization in a data center. If you have a 200 employee organization, you have data center servers, and they're running a RAID array of disks in network attached storage or a storage area network. You can be dealing with many terabytes or exabytes, thousands of gigabytes, right? When you deal with 1,000 terabytes, you're dealing with an exabyte. When you're dealing with 1,000 exabytes, you're dealing with petabytes. You can be dealing with huge amounts of material. And the important thing to understand is that you have some special hardware concerns when it comes to the acquisition of a whole hard disk. If we were talking about a desktop, if we were dealing with a workstation in an office or a laptop, we would simply remove the physical hard disk, and we could connect that physical hard disk using a hardware write block, a hardware-based write block, and we could copy that entire hardware, that hard drive, including any of the hidden sectors, including data that's on the disk before we even get to partitions. And that's easy when it comes to laptops and workstations. And the same is true of mobile devices. You have SD cards, they're limited in size, so you're not dealing with an issue. But if you're dealing with a corporate environment and you're dealing with RAID, you have disk sets and you have very large disk volumes, very large partitions. And so one of the things to do is to collaborate with the IT staff. If you pull a disk out of a RAID array, there are some data recovery tools that know how to pull the data from a RAID member. And essentially, the IT shop can put an empty hard disk in its place, and the organization goes on. The image on that disk is rebuilt, and it becomes a member of the RAID set again. Let's see if we have. See if we have. So it talks about pages 125 to 133 of the textbook. So there's a case where there's a direct reference to the textbook. So I hope everyone has a copy of the textbook. Would anyone like to see pages 125 through 133 of our textbook?
I'm good.
Okay. So just remember that when we're dealing with RAID, we're dealing with a special case. And oftentimes you're dealing with collaboration issues with the IT shop. If you have a large RAID volume, so mailboxes are a great case in point. Email boxes can be very, very large, depending on the organization and the commitment they have to the use of email and how critical it is to the operations of the organization. It's not uncommon to find 100 gigabyte or 500 gigabyte mailboxes. And that's just the mailbox. So that's one PST file. One PST file on the email server can be 500 gigs large. Of course, those are rare cases, but the point is, you have this breakout of disk data collection methods. And what's important to understand is how they're ranked. So if you can get an entire disk to image, this is the ideal case where you have a physical hard drive and you're capturing the entire image of the physical hard drive, right? So you're basically capturing an image of the entire physical hard drive. And that has the greatest flexibility, and it's the most common method used. In cases where you have older hard disks, there are special circumstances where you have to find a model of the precise brand, the precise brand and model of the same disk. And you use that hardware-based write block. And if you have a Seagate 1 terabyte, 7200 RPM model such and such, you need a Seagate 1 terabyte model such and such, and you connect the two, and you can connect this. You can basically clone or duplicate the physical hard disk precisely to the other hard disk. The reason the image method is more common and more flexible, it's generally the case that you have a much larger capture capability. It's not uncommon for digital forensics specialists to have their own local storage area network, a very large disk capacity, so they can take terabyte hard disks, several at a time, and just suck up the whole thing as a single image. They're not worried about physical hard disk to physical hard disk captures. So I'm talking about static captures now. Remember that when you're performing acquisition, there are basically two main components to acquisition. There's live acquisition, and there is static acquisition, which gets us back to our solutions. I wanted to clarify a little more. There have been a few questions along the way. In your acquisition solution, you have two solutions that are due, the acquisition solution and the analysis solution. In the acquisition solution, you have two components. You have a live acquisition that you perform on the running workstation that belongs to Sydney Corinth. It's set up in a notional environment, and it's sitting there running for your access. You coordinate access with the IT department by coordinating a change of password. The system is locked. There's a number of things that are running on that system. And your first order of business, since this is an informal private internal investigation, is to help stakeholders at AAFES to understand. Hopefully you've been reading all of the related documentation, all of it, because you're going to miss things if you don't. But basically the first phase of that acquisition solution is to get on that screen and get screenshots. Now, if you've had problems logging in, either coordinating a time slot yet, or getting the login details to work, or getting the login details at all, you still need to contact me. There is some time. We extended the deadline. Any questions about the live portion of the acquisition at this point?
No questions.
Okay. There is a static portion or a static component of acquisition. So instead of being live on site in person with running machines, you may have disks. You may have a physical hard disk. You may have a USB thumb drive. You may have DVDs and CDs. You may have SD cards. But basically, you have different forms of media that you can collect as evidence. And then basically, you're performing a static acquisition. The static acquisition is significant because you cannot and should never, did I mention the word never? Should never perform analyses of a collection of media that's been collected directly on that media. That digital evidence cannot be modified or changed, or it loses its value and integrity as digital evidence. Put another way, you ruin the case. You become the poster child for how not to be a forensic specialist. When you're collecting all this evidence, you may have a set of storage media that you have collected, and it is digital evidence. But in order to perform your analysis on each one of those disks, right? So there's going to be a series of analyses, right? The plural of analysis, right? Going to have independent analysis of each of those media sources. You have to make digital copies. You're working in the acquisition phase, the static acquisition phase, to create precise equivalents, digital images, identical copies of the media that's collected. So you're making copies of any CDs and DVDs. You're making copies of any floppy disks, if you happen to have those, or any USB drives. If you have any tape media, you're making copies of all that stuff. And that's what we were talking about here in our addendum, okay? You're going to have all these different types of media. And if you have a very large storage capacity, you can basically make precise digital images of the entire disk. And that's the most ideal, the most common, and most flexible method. When we talk about very large independent capacities, I want to share with you some very cost-effective I want to show you this. So there is a company called Disk Robo, but there are a lot of competing companies that do this kind of thing. And what you can purchase are small cases that allow you to power on a set of very large multi-terabyte hard drives. So let's pretend we go to Office Max today and we order this D-Robo. And this is probably 16, 18 inches wide. And if you looked at the side of this thing, it's probably 18 inches deep. There's power supplies in the back. There's a series of data interfaces in the back. And basically there's a way to connect this to your workstation, your forensic workstation, or your laptop. So let's say we have 2 terabyte hard drives, 2, 4, 6, 8, 10, 12, 14, 16 terabytes. And let's say that I wanted a large mirror set. I wanted a redundant array of independent disks. Why do I want redundancy? Well, in case one of the disks fails, I want another disk to back it up. So I'm going to split the set of 8 disks into 2 pairs of 4 disk arrays. And I'm going to mirror those 4 disk arrays. So I'm going to form a RAID 1 mirror with a 4 by 2 gigabit, terabit, 4 by 2 terabit. So I have an 8 terabit array. And then I mirror that array. Okay. We'd call that a RAID 1.0. So if we stripe these together to form an 8 terabyte disk, and then I do the same thing here, I can use this RAID 0 striped 8 terabyte array to be a backup for this. I have a total storage of 8 terabytes, but it's redundant. So if any one of these disks fails, I have a chance to pull the bad drive out and put it in. This is the same kind of thing you see in data centers, by the way, with RAID. So if you look in your textbook on those pages, it explains RAID. If you pull a RAID member out, certain types of RAID members, if you have like a RAID member on a RAID 0 array, it's no good to you because it only has part of the data. What do I mean by that? In this 4 disk RAID 0 stripe, this is called a striped array. RAID 0 is the most basic type of RAID array possible. So it's striped, meaning if I have a 4 gigabit movie, let's say I have a 4 gigabit video and it's 2 hours long and it's a wedding and there's an event at the wedding where somebody insults someone else and it's evidence, right? Everybody with me so far?
Yes.
Okay. So if I have this 8 terabyte RAID 0 striped array, and I put that 4 gigabyte video, wedding video on here, one of the gigs is here, 1 gig is here, 1 gig is here, 1 gig is here. What am I saying? The 4 gig wedding video is split between those 4 disks. If I lose one of the disks or if I capture one of the disks, I only get part of the wedding video. I don't get the whole wedding video. In fact, I don't even get a segment of the wedding video. I get like parts of the bits of each second. So I can't even make sense of that data, right? The important point to understand is that there are some types of RAID that make disk and data recovery a lot more complicated. And RAID 0 is a special case where the data is stretched across all 4 disks. So if you grab one of the disks, you don't have a copy of that. But let's say we had 2 disks that we used in a RAID 1 mirror, a mirrored RAID disk array. I have a 2 terabyte here and a 2 terabyte here. This disk serves as an exact copy of that disk. So I have a pair in a RAID 1 mirrored array. When I put the 4 gigabit wedding video on that RAID array, a 4 gigabit copy of the wedding video is here, and a 4 gigabit copy of the wedding video is there. So if I were to acquire a RAID 1 disk, when I pull the RAID 1 disk, if I replaced it with an empty RAID drive, just like this one, it would rebuild the array, and this thing would go on like nobody's business. It would basically say, okay, one of my disks went bad. I don't know where it is. I don't know what it is. Oh, here's a replacement. It's empty. And the RAID 1 mirror would rebuild. So all of the copies on this one would move a set of data, exact data, over onto the other disk. And you'd have this separate disk that you pulled out that was an exact copy. The only problem is that that disk is a member of a RAID array, and it isn't recognized like a physical hard disk out of a hard drive, or out of a PC, out of a workstation, or out of a laptop. When it's a RAID 1 mirror, it's a member disk of a RAID 1 array. So you have to have software, data recovery software, that understands how to speak that language. So in the case that you want to recover data from RAID 1, you can. RAID 0, you can't. RAID 5, it's complicated. RAID 5 does some weirdness. I don't recommend anyone using RAID 5 unless you're dirt poor and you don't have money and you have to go really cheap. The best of both worlds is to combine RAID 0 and RAID 1 in a RAID 1.0 array. And so I just wanted to talk about this, but basically 2 gigabit or 2 terabyte drives. Let's just take a look here. Let's go shopping. We'll go on to Newegg, and I'll look at, let's see. I don't want computer systems. I want components. That's what I want. I want storage devices, hard drives, desktop internal. The thing you want for your kind of work is not a desktop. It would be called an enterprise internal hard drive. Okay. So not an external, but an internal. Then you have controller RAID cards, right? So you have all these other accessories, but let's take a look at what we have here. Whoops. Yeah. I wanted that one. Okay. Wow, they've gotten very large, haven't they? So you see the word enterprise? Does everybody see the word enterprise?
Yeah.
Okay, so enterprise means, okay, this isn't for a desktop. This is for a data center. It's for a server. It's for a network attached storage, or a storage attached network. And those work a little differently in each case, but it's just a very large disk array. We go into that when we talk about computer architecture, and we go into it more in operating systems. But basically, you see the 2 terabyte desktop hard drives are not that expensive, $55 each, right? And if you get an enterprise class machine or an enterprise class hard drive, they're more expensive, but they're built to better standards. So this one not only has, it's available in 1 terabyte to 18 terabyte capacities. So in this case, if you buy the 18 terabyte disk, wow. Okay, what would an 18 terabyte disk mean in an outfit like this? Well, 18, 36, 48. 64 terabytes. 64 terabytes of RAID 0. By the way, that's 4 times as fast. So when you do RAID 0, every time you add a disk, you double, triple, quadruple the speed of read and write accesses, right? So that's 4 times as fast on the read and write. It's 64 terabytes of space. And if I do that again, I have redundancy. But how much does that cost to do each time, right? Well, in this case, we're dealing with a $600 cost. So this enclosure would run you about $1,000, then 600, $1,200, $2,400 per set. That's $4,800 plus 1,000 for this. It's $5,800. But you have a huge amount of data you can capture, which means, well, you have a lot of capacity to do disk to image captures, right? So when we talk about equipping a forensic laboratory or a forensic professional that's got a growing practice, these are the types of business investments that you make, right? Let's look again at what we were talking about with the disk types. If you have clients that use a specific, like they use Barracudas or they use Seagates, so they have Seagate Barracuda drives in their data center. It pays to have a set of Seagate Barracuda hard disks, so you can swap out hard disks on RAID 1 mirrors and RAID 1.0 mirrors if you need to capture data for a certain acquisition. But this is static acquisition we're talking about. So in your assignment, when you're talking about the static, the solution, you have a single 1 gigabit thumb drive. Has anybody had problems getting the thumb drive since we changed where it's stored? Has anyone had any difficulty getting the USB image? Anyone?
No, not really.
Okay. So you have like the equivalent of a 1 gigabyte thumb drive. It's actually a VHD, and you attach it, and it has to be attached read only. And that's like plugging in the physical USB drive to your laptop or your PC. You run 2 static acquisitions, not 1, 2 static acquisitions, one with Geimager, and that's in Kali, and the other one with FTK Imager. You download from the internet and use that to acquire. Now, why would you use a commercial product and an open source product to capture the USB? Well, in a previous class, we noted it was important to do that because it shows you can duplicate your results, that you can, validate that you get the same results no matter what tool you use when you capture that USB drive. So the hashes from the Geimager acquisition and the FTK Imager acquisition have to match. Once you have the screenshots from the live acquisition and you have the 2 USB captures of the same USB media, then you've completed the acquisition solution. And then you're ready for analysis. When you start your analysis inside Autopsy, Autopsy is a web interface for a series of forensic tools. So it gives you this point and click ease of use. And if you follow along with what's happening here in Autopsy, as you import the disk image media, right, as you bring in the media that you captured, it'll generate another hash. And that hash is important to validate against the original hash. What am I saying? Well, when you begin your analysis, let's say that you have your images stored over here, and 2 weeks later you get to the images. Well, you have to prove in court, if it ever gets to court, right? If somebody challenges, and even for a private internal investigation, let's say Sydney Corinth doesn't agree with her termination decision. She was terminated by APHIS. And part of the reason she was terminated is the evidence you provided, right? So let's say she says, I'm going to sue AFIS. I'm going to sue the forensic specialist. They're wrong. You have to be able to show, okay, I did my analysis on this disk image. Here's the hash of the disk image I conducted the analysis on using autopsy. And here's the hash of the original capture. You see those two match. Why is that significant? It shows that you didn't modify Sydney. It gets you off the hook. It shows that Sydney Corinth can't blame you for modifying what's on that USB thumb drive. If you captured it properly when you first laid hands on it, you have this hash that shows here's the original condition and content. And when you conduct the analysis, you say, okay, here's the copy. And the copy is what? Identical. It has original image. It's just like the original image. It has the same content, bit for bit, byte for byte. That's what you're doing in the 3.4 solution. Any questions? Any questions about our two solutions?
No, sir.
Okay. Let's get back to this just briefly. So logical disk to disk or file. What do we mean by logical disk? So when we're talking about the whole disk, what you see here is a virtual or graphical representation of my physical laptop hard disk. So this is like the physical hard disk itself, this little box, all right? And it's just represented in disk management as this little box. And there are certain features and attributes you can noodle with, properties you can look up and so on. It's online or offline. Sometimes you can't access a disk because it's offline. You notice here, it says offline. If this disk were connected, but it wasn't live or active, I'd have the opportunity to take it offline. And when you try to access it, it'll say, oh, disk not found, right? And this is a classic dodge by people who are trying to frustrate forensic specialists. So what you're going to do is simply take it online, right? That's so you can access it to get the copy. The best way to do this is physically. So you remove the disk, connect it to a hardware device with a write block built into the hardware, so you can only read the thing, you can't write to it. But that's the physical hard drive. Inside are partitions, and when you have one that's used for data use on the system, that's called a logical drive. Usually they have disk letters, but not always. So in this case, drive letter C is a logical drive. If you can't get a copy of the entire physical disk, let me say that again. If you can't get a copy of the entire physical disk, then you can get a copy of the logical disk. You can capture the logical disk. The ideal is to get the entire physical disk and to capture it to an image. If you can't do that, the next best thing is to have the same brand and model of hard disk, and you get an identical hardware copy disk to disk. That's the next best thing, right? And if you can't do that, then you get a copy of the logical drive, right? That's drive letter C. And then in the last case, it's called a sparse copy. So this is like a worst case scenario where you have this huge data center. Let's say you walk into a company and they usher you to the back of the data center and they say, here's our storage area network, and it's 3 exabytes large, which means I have petabytes, which means I have terabytes, which, oh my gosh. Well, your organization, you're hired to investigate just one person and one situation. You're obviously not going to capture that entire data set, right? You're not going to capture the entire volume. You have to surgically figure out what you're going to do. In many cases, when people are set up on a corporate system, they have what's called a drive letter map. What we mean by that is there are shared folders on a large data center array. Could be a storage area network or a network attached storage, or just a set of disks connected to the to an actual server, right? So that's called direct attached storage. When there's a SCSI cable out of the back and it's connected to the motherboard directly instead of to the network. So storage area network and network attached storage are network-based disk arrays. Direct attached storage means it's connected to the motherboard of a server. Either way, you have this huge disk for user directories and user home directories. And oftentimes a user file or folder is shared. And when it's shared, it's then mapped. So when they go to a workstation and log in, it has a drive letter. It could be drive letter H for their home folder. So H for home directory. And in this case, I'm going to map it to myself just so you can see how this works. So in a corporate setting, what happens is that there's a shared folder. It has permissions. Only the user that the folder belongs to has access across the network. There are NTFS file level permissions. Basically, when they log in, there's a login script that connects this, and the H drive is there. And so here you see on my ThinkPad, I not only have a C drive, but I have a network drive map. It's a drive letter, but it's connected through the network. Okay, if I look at this differently, it's drive letter H, but it's a network drive letter. The only type of acquisition you can work in this case is the last type of acquisition, the sparse copy of a folder, meaning a directory or a file, right? So you use this only when the whole disk is not needed and you want to recover deleted files, right? There is an international standard. It's the ISO 27037 on page 98. It says you need to take extra care when you're working with sparse copies. If I had a copy of ISO 27037, an up-to-date copy, those are usually $100 a piece. I might be able to show you what's on page 98, but basically it's telling you that you have to take extra care to make sure that when you're recovering deleted files from that folder, that you're actually getting the user's deleted files and not some other disk sectors because it's in an array. Essentially what they're saying is, hey, with large disk sets, there could be bits and pieces of that directory all over these disks. So you have to take extra precautions. Does that make sense?
Makes sense.
Okay. You're going to find that quite often you have to perform a sparse copy simply because in a large, mid-size and larger business setting, if they have a data center, they're not going to give you a hard disk. They can't. They're going to, the IT shop is going to say, well, we have a huge array of disks and each user has their own home directory. It's their usable profile disk, right? It's where we store their user profile. The user profile meaning you have roaming profiles. This is another cute little thing that drives forensic folks nuts. Normally, a user profile is stored in the user's directory. of a local hard disk. And in this case, I have an owner login, and this is my user profile. In a networked environment, in a corporation, you can basically put that here on a network, a very fast network storage array, like a SAN, storage area network. And you can basically map that user profile in its entirety. So when I click into here, what do you see in here? Well, you see my documents, my desktop, those are all separate directories. My favorites, my music, my videos and pictures, but basically my documents, right? You see all of the different things that belong in my user profile. So when I'm in Windows and I'm looking at this, it's pulling to the C drive users folder to my profile. What's often the case though in a corporate environment is that that entire directory, all of this is roaming. So as they log into different systems, they get an H drive, but it's coming off of this in the data center. It's not coming off the local disk, right? And I wanted you to, so it's going to be in here under H, and desktop, documents, downloads, music, pictures, videos, those directories are actually redirected to a network volume that's loaded automatically when they log in, okay? And that can really confuse the heck out of forensic folks, but I wanted you to be aware of scenarios like this. And so that's one reason why sparse copies are such an important matter of discussion in mid-size and larger organizations. You'll have whole disks. They may have a laptop. There's an entire physical hard disk that you can capture to image with a Linux workstation, or you can capture it with a hardware-based write block tool and capture it to an image. And so the image can be stored separately. And again, that's an image of the entire freaking hard drive, physical, right? Physical. I'm talking about the physical hard drive. So this square box logically represents what that entire physical device is right there. Now, here's the catch. The first two methods, you'll notice, involve the entire disk. The next two methods involve a logical disk, and there's extra stuff in there. And a sparse copy, it's actually directories. So the further down you go, the less desirable it is. Why is it less desirable? Very bad people like to hide, especially people who are doing really bad stuff. Weapons, human trafficking, drugs, international terrorism, child pornography, that kind of stuff. People hide that kind of data in other partitions that are not typically accessible. One trick is to attach and to detach VHDs so that they're kind of like plug-in USBs. Let's face it, malicious actors are getting more and more sophisticated, but the thing we want you to understand is that there are additional data storage areas. In particular, when you create a new disk, there's extra space inside the disk sectors itself. I wanted to explain, did we explain about slack space? I don't think we explained about slack space before. I'm going to create a small VHD just for demonstration purposes. Okay. So we're going to create a virtual hard disk like we had a real hard disk right here. And I'm going to call this small USB. Okay. Everybody with me so far?
Yeah.
All right. And I'm gonna make this, let's make it a half a gigabyte, okay? So it's not gonna be that big. It's not even gonna be a 1 gig disk. It's gonna be a half of a gigabyte. It'll be a fixed size. And there it is, creating the VHD. And it hasn't been initialized. I'm going to initialize the disk, meaning I'm going to plug it in and power it on. That's what you're doing when you're initializing it. I'm going to put a standard master boot record instead of a GUID partition table, the newer format, which is much larger, right? And then I'm going to format it. I'm going to format this so that it's usable. And yeah, so it takes up some space to form the partition and to build the logical drive. Here's the part that I want you to see. The allocation unit size. In Linux, these are called inodes. When I format the disk, I'm creating small chunks on the disk. And those are disk sectors, right? We've talked about this before, yes? Maybe? No? Anybody?
Maybe.
Maybe. So I'm formatting this. So now this appears like a thumb drive, a USB drive, all right? And if I were to look at this and look at its properties, it's formatted with NTFS. And if I go deeper, I find out that each allocation unit, each chunk of data that's formatted on that disk is exactly 4 kilobytes large. 4 kilobytes large. Okay. Now I'm going to do something here. I'm going to create a hidden document. So I'm going to type in secret, right? Secret.txt. I'm going to open this up and I'm going to put a single character in there. There's my secret. I know that's kind of a stretch, but I'm going to close this and save it. How much is that exactly? Well, it's got 1 character in there, and a single letter X is represented by a single byte. What's the size of the allocation units I put? All right, let's do this again. Let's take it a step further. I'm going to change the name of this from secret to secret 1 and secret 2. Everybody with me?
Yes, sir.
Now I have a second secret. I got to open this up. I'm going to type in the letter Y and save it. So it says the size is 1 kilobyte large, but that's not really accurate, is it? No, it's really only 1 byte large. The only reason this is showing 1 kilobyte is because size is set to show the nearest kilobyte. So here's the fun part. When I go into my allocation units, there's 4 kilobytes or 4,096 bytes, 4,096 bytes for each allocation unit. Question: are each of these 2 files stored in a single allocation unit or in different allocation units?
Different units?
Different allocation units. That's right. And how much extra space do I have in each of those allocation units? If I take up 1 byte and I have 4,096 bytes in each allocation unit, how much space do I have left? It's not a trick question. What's 4,096 minus 1?
4,095 bytes.
4,095 bytes. That's called slack space. I can't put anything else in that allocation unit. What? You heard me. There are 2 allocation units on this disk now that are taken up, each one with a single byte character to a text file. There's a name of that file, right? That's stored in the file allocation table. So that's called metadata, right? The file name, where it's stored, the directory, the path, that's all metadata. The owner, that's information about the file itself. I can look at that in the hex editor and get some of that information. I can look at a hex editor and see if the header reflects the kind of header that I would see for a text file, as opposed to a JPEG image file, as opposed to a database file, as opposed to an Excel file. There are all these different headers, right? I can look at that with a hex editor and look at the hexadecimal data directly. But one thing I'll notice is that there isn't a whole lot in there. That entire allocation unit, 4,095 bytes, is empty. And nothing else, the file system isn't going to put anything else in there. So if there's extra space in the allocation unit, it's slack space. And that's what hackers love. They love to stuff hidden data inside the slack space. That is one reason why capturing the entire physical disk is a good idea, because not only do they hide data in slack space in a logical volume like the C drive, but they also do it in hidden partitions, right? They'll even do it in the hardware sectors of the disk before there's any partition. The really sophisticated ones will write on the hardware level. So they'll hide it before there's anything written in that table. Those are the really sophisticated, like nation state specialists that are hired by their governments to hack other governments. And then you have the skilled hackers that know how to hide stuff in hidden partitions and in slack space. And then you have the garden variety person who basically hides it by changing the attributes and saying, okay, I'm going to hide my data by doing that. And so if you're not viewing hidden items, it doesn't even appear on the screen, but it's there. So that's what garden variety people do when they're hiding their trail. They do hidden items. The important point to remember is that you lose more and more to work with the further down you go. So when these 4 methods in the textbook, which one's best, right? It takes a lot more hard drive assets to do this first one and the second one. Obviously, you have to have a lot of disks and disk capacity. But the further down you go, the more you lose in terms of data storage areas where a sophisticated hacker could stuff some things, could hide some things. We've already talked about what's the name of the method where you hide one application inside another. We've already talked about that. Does anybody remember that one? Does anyone remember the name of the method where you hide an executable inside another executable? Anyone?
Alternate data streams.
Yes, thank you. Alternate,
I'm sorry, I didn't.
yeah, alternate data streams. And there is another method, related method, called a forked resource. So alternate data streams is like it's like a method of a forked resource, right? Conceptually, it is a very simple thing to perform. If you haven't done it yet, if you haven't performed this thing yet, right? You can do it live by typing out or using the cat command to output a text file and then hide it like this. There's a very simple syntax though, by the time you actually perform this thing. When you're running the program, you have to use the start command, the host program with a colon followed by the bad program, right? And if you know to use directory /r, it'll show the ADS, it'll show the alternate data streams. It'll show that somebody's done that on the screen, where you'll actually see the colon listed, okay? But it's, see, even most intrusion detection systems can't catch this. Only the latest, greatest ones can catch this kind of thing in transit, right? Let's talk about network tools. We need to talk a little bit about network tools. So you have an assignment that involves Nmap. So you have one final assignment that involves GRC, netstat, and Nmap. I wanted to clarify that you're using your own home network environment to simulate the work network environment for AFIS. Everybody's going to get a different result. And if you haven't loaded Nmap or ZenMap on your laptop or your desktop, you don't have to actually do this to complete part 3. What am I saying? Each of you should have access to Kali, right? And if you downloaded the appliance and installed the appliance, or if you downloaded the ISO and installed it directly and then did some of your own things, you do have access, by the way, here, when you go into here, and you go into forensics, and where do you find Geimager? It's right here. That's where Geimager sits. That's where autopsy sits, right? Inside the sleuth kit suite. How do you use Nmap here? You open a prompt. It's best to do this with elevated privileges. So you want to enter the command sudo su for super user. It's going to ask you for the Kali password, which is Kali. The first time that you do this, you're going to get a scary message. I thought I would share this with you. So yeah, you're going to get this. We trust you have received the usual lecture from the local systems administrator. It usually boils down to these 3 things. Respect the privacy of others, think before you type, and with great power comes great responsibility, right? So it's a banner. It's a splash screen. The first time you enter sudo su, it's going to say, hey, wait a minute now, you're getting serious here. And that's normal. That's the first time you do it. You don't get it the next time you do it. You didn't see that just now. It didn't warn me the same. But if I type in Nmap, and then, well, first thing I want to do is just look at where I'm sitting. I would use ipconfig in a Windows machine, but on Kali, I'm going to use the term ifconfig. That's going to tell me where I'm sitting. I'm sitting on the 192.168.1 network /0. The net mask is a 24-bit network mask. So when I issue the Kali command, this comes back to your days in networking. Yes, CSE 243. Does everybody remember that? Hopefully.
Yeah.
Yeah. Okay. So you're going to do Nmap, and you can do something like this. If you're allowed permissions, you can do different switches. -O would be operating system detection, right? So it's a little more thorough. You can do an entire range, 192.168. 1.1.0/24. That's going to start a scan. And what's important is that you're going to get results. You're going to get results on the server side from GRC Shields Up. You're going to get results from Netstat on the client side ports that are engaged with different hosts. And then you're going to get Nmap. And what you want to do is try different, you want to compare the results with each other to see if there's something in common. You see here the specific switch I'm telling you to execute, right? -SV, -SX, those are safer commands to run. In any case, you should have permission to run them on your local network. I'm assuming all of you have permission to test your network at your house. If you don't have permission to test your network at your house, we need to talk. In any case, this is going to take a bit to run. And yeah, I want to make sure I actually have network connectivity here. So I'm going to ping Google. And it looks like I have DNS and I have network connectivity. I'm going to Control C to stop this, otherwise it'll run forever. I will run a different command. On this side. That's the coolness part. I can open up multiple prompts. I can do things interactively between tools and such. I can actually run an Nmap scan while I'm simultaneously executing an ncat command or other things and then see what happens over here. But I'm going to go ahead and actually use the, was it a capital V? I think it was a capital V. So -S capital V or -SX. So let's do that. And I'm going to go ahead and redirect the output to an nmap.txt file. So yeah, when I'm using the -O, that's a deeper scan. This is something you would do. It says 252 hosts completed, 3 undergoing SYN stealth scans. So the -O, I think, is operating system detection. If you have permission to run deeper scans, that's a good thing to do. But I'm going to go ahead and repeat the same thing, only with a different switch here. I'm using CIDR notation for my subnet mask. And I'm going to do a third one. Just because we're running short on time for the class. And I wanted to show you what happens here. I'm going to run Nmap just against the network without doing anything else. So no switches, right? So I'm doing Nmap by itself, no switches. I'm doing Nmap with a -S capital V. And I've got this one, that's the deep scan. There's something called a Christmas scan that's really cool. If these are things you can only do if you have permissions to go deep. But basically what you're looking for are IP addresses with corresponding ports that are active. And you want to compare those against the results that you get from GRC and Netstat. There should be some there should be some similarities. There should be some points of comparison, or something is going on with your network, right? And we wanted you to get a feel or a flavor for how these tools work. What's most important to understand is this idea of capturing the output with a redirect symbol and then a text file, right? In Kali, it's actually simpler. I can repeat the same command, right? So in this case, I did a very basic Nmap with no switches, and it gave me two results, the ThinkPad and a server, and it gave me the results. So there is a default, right? If I do the -SV, I get a little more detail. Well, I don't know, how much more detail do I get? 1.1. Yeah, different kinds of detail. So the I get a little additional service information here, right? And that's telling, because it helps me understand if something's going on in my neighborhood. You might have an Internet of Things device that is lurking, or it's being used as a pivot point. It could be a compromised service provider internet router. It could be a compromised intelligent assistant like an Alexa that's infected. You get all sorts of interesting things. But the -SV gives you information about service, and that helps you pin down the operating system that's there, right? So you see the different levels of results. What do I have over here? So I still have quite a bit of, it says 92% done. I'm almost getting a result here for my deeper scan. The important thing to note here are the MAC addresses. Sometimes with network attacks, you have people who are spoofing MAC addresses. If you check the MAC address and it doesn't match the manufacturer, you know, this is supposed to be an Intel chipset in my ThinkPad, but sometimes when people are spoofing MAC addresses, you get mismatches. It's really obvious, right? The important point to understand is that network forensics is ephemeral. The results you get can change in an instant. It is considered a best practice to redirect the results. So if I just hit my up arrow key and redirect the results to a text file I call test.txt. It's going to capture my output. A lot of terminal screens have a limited amount of buffer. So if you have a volume of information resulting, this is another challenge with network forensics. You have this sudden run on information, and oh my gosh, the screen is filling. It'll overrun the buffer in the terminal. If you have a 4K buffer in your terminal window on average, and the output is 12 kilobytes large, well, you're going to miss the first 8 kilobytes. It'll stream right past you. So even if you scroll back, even if you try to copy and paste, it's just a best practice to capture the text. When I do a list, and I look at test.txt, I can see what's in there by just using the cat command, cat test.txt. And it's output that text file to the screen, or I can open it up in Nano. That's another good thing to do. I'm going to put test.txt. Obviously, I have to be in the right directory or I don't. Oh, I see what happened. I misspelled it, so it's text.txt. I'm going to exit out of this. Let me repeat that, but I'll spell it correctly this time. There we go. So Nano is a basic text editor. It's easy to use. I like it a lot better than other native text editors. But anyway, you can once you have these data files, you can do all sorts of data analysis on them. You can munge. It's called munging, where you slice and dice the specifics out. You can search for specific IP addresses or specific ports. The important thing to understand about network forensics is that if you don't capture the output to a text file, you can't go back and pick through it. And sometimes there can be a hell of a lot of detail. Are there any questions about your final assignment and sensibilities with respect to network forensics? We did have an entire course centered on network forensics. And why is that saying this is hidden from students? This should not be hidden. Was anybody going to say anything? Hey, I'm not seeing that solution. Not seeing that assignment. Everybody sees it now, right?
I'll go check Blackboard.
Okay. I'm going to bump this back to the end of the week. You have until May 1st, 11:59 p.m. to finish that last assignment, right? If anyone needs more time, I'm going to bump this one back to 11:59 Saturday. Right. I'll change the header on that as well. Are there any questions before we close out for our last class?
I have a quick question.
Yes.
So we're learning all of this, right? Could we be able to use it? Say we're going to work for a company. How would we, like, how would that process be of displaying our skills, you know, to make some decent money?
Okay. So you've taken a course in forensic, digital forensics at the University of the Virgin Islands, and you had intro to cyber, right? And and what I would recommend is that you take the rest of the courses in the concentration. When you finish the concentration is designed to prepare you for industry certification. Are you familiar with Network Plus?
Yes.
And Security Plus?
Yes.
Okay. So what you do is you have the knowledge now and you brush up on the content and some of the practical hands-on skills, right? So you're gonna do that. And if you're interested in doing this professionally, what you'd want to do is take this $370, right? I think it's $370 for the voucher. There are study guides. We're thinking of offering like a summer boot camp or a night course boot camp through UVI Cell to get people, once they finish with the concentration, if they'd like. Our existing concentration is focused more on forensics, digital forensics, network forensics, mobile device forensics, software forensics, we call malware analysis. So in that case, you're looking at a forensics investigator credential. Those are a little more sophisticated, right? So you have EC Council, the computer forensic investigator. You also have SANS forensics certification. Those require training in addition to the courses that you're taking now. And in this case, the exam, all right, so the CFE, the Certified Forensic Examiner, then you have the CFA, Certified Forensic Analyst, right? This is more like the incident handler. This is more like the specialist that's analyzing the data that was captured. So this guy does more incident handling and evidence capture. This guy does more of the analysis on the back end. This is a specialist, of course, in malware. So that's reverse engineering of malicious software. And then network forensics. So SANS has a whole slew of different specialty certifications, but each of these exams are $500 and you have to attend a week of training. You have to wait 30 days after the training before you can take the exam. SANS is very rigorous, but very valued. The entry-level certification from SANS is called the 401. It's equivalent to the Security Plus, right? So you would want to, you likely want to certify, because the moment you start doing professional forensic work for pay, it's not long before you have to go to court. When you start doing things, professionally and people's livelihoods are on the line, their workplace security is on the line, you know, there are legal issues that are on the line. The moment you step into court, the first thing that's going to happen is somebody's going to go, all right, so who was your consultant? If you're an informal consultant for the IT shop, for the IT staff, because you know more about cybersecurity and forensics, that's appropriate. And they'd call you to the stand and they'd say, okay, what's your training and background? How do we know you're an expert, right? And you'd explain the kind of training and exposure and activities and experiences that you've had. If you get one of these, when they call you to the stand, they say, are you certified in any of these forensic discipline, you know, cybersecurity disciplines? You say, yes, I am a certified ethical hacker. I am certified by the EC Council. It's an international organization, 75,000 certified professionals worldwide. And that's one of my current credentials. So at that point, the attorneys shut up and listen to what you have to offer, as opposed to questioning your experience and your expertise, right? So the short, I know that was quite an answer, but if you're going to do it for money, after you finish at UVI, the next step is to get an industry recognized certification so that you can vouch, this would vouch for or stand in place of, this lets everybody know you have like a seal of approval. This is kind of like the boards when you have, you know, nurses and healthcare people, they have to go through like a board certified process. This is the equivalent for cybersecurity professionals. Does that answer your question?
Yes, thank you.
Okay. I mean, at that point, then when you're at the work site, you say, you know, here are my credentials. Here's the additional training I've had. I've had coursework at the university. Here's my transcript. Here's the experience. You know, here's some of my clients, right? I have satisfied customers, right? And then off you go. That was a good question. Thank you for asking it. Any other questions before we close?
Let's see, I was doing the 3.4 assignment,
Mm-hmm.
and I noticed that, you see, the My Sheet home text wasn't there, and the Amber text wasn't there either.
Sometimes it has to do with the way the browser renders the graphics in the browser window in the tab. A lot of times it has to do with the virtual machine, and sometimes changing the settings on the virtual machine to increase the amount of display available, right? Or to enable 3D graphics. Sometimes it's a simple fix, right? So if it happened in Kali in a virtual machine, there could be a number of factors. My suggestion would be for you to arrange for a screen share. Let's take a quick look at the difference in output for the OS scan, right?
You know, like I saw the notes, I saw notes restricted, I saw those,
Uh-huh.
but I didn't see the other ones.
I would suggest arranging a screen share and getting to the point where you can show me what you're talking about. Okay,
All right.
all right, that would be the next step. Any other questions? What can you expect for the rest of the season? Well, tomorrow is the study day, right? We're going to be making the assessment for module 3 available. And as soon as most of the class is finished, we're going to put an item analysis out and the retake. The exams are next week. Your exam is officially, let's look at this. Your exam officially your exam officially is posted Thursday morning on the 6th of May at 8 a.m. But you have until Saturday 12 noon to finish the exam. So you don't have to do it. It's not I'm not going to monitor the exam. It's not a proctored exam. You'll have a 2-hour window to complete a final exam, which will include any and all concepts and methods and assignments that you've had in all of the modules, right? So you'll have 2 hours to complete that final exam. Once you start, you can't stop. But the 2-hour window ends on Saturday at 12 noon. Are there any questions? So you'll have ample opportunity to complete. Did everybody know that we don't have classes on Thursday and Friday, but that's because of Carnival that was originally scheduled? Even though it's canceled, the university has not rescinded that those days off. So does anyone have any classes tomorrow or Thursday or Friday in any of their other classes? I didn't.
No, I don't think so.
Not to my knowledge.
Yeah, I didn't think we did. So in January or December, we had the Carnival in St. Croix, and there was downtime, and now it's St. Thomas's turn. So basically, you need to have everything wrapped up by 11:59 on Saturday to finish up this module with the assessments and the assignments. And then you have a little bit of extra latitude here. If you need more time, if you just send me email, I will post the exam on Thursday morning at 8 a.m., but you don't have to take it at 8 a.m. You have until noon on Saturday, and that's the timeline. Does anyone have any other questions before we clear?
No,
You were
sir.
saying that you was we could have got a little bit more time with assignment 3.4.
I'm saying that if you need more time, you can send me an email and ask to have, if anybody needs more time and they would simply request more time because of, other priorities, other classes, other exams. Once I extend that for one student, I pretty much send a notice to everybody and say, okay, the deadline's been extended.
Okay.
So that's,
So, see, you could Zoom at 4 today.
hang on a sec.